Good morning, algebra class. I have an appointment this morning and hopefully we'll be back. I should definitely be back before the end of the second hour so I can take any questions you might have and we can talk about the test or whatever. But I knew I wouldn't be at the beginning of second hour, so I wanted to at least get you started by giving you a video of the rest of the review that I handed out yesterday. So, couple of things before we jump into that review and do the last 5 slides. First of all, if you're in class today, there are copies of that study guide if you want to get it. Laying back on my desk, I've got a note on it for the sub to hand out. Second, well, here we go. Let's talk about a couple of things. Test procedures. So, test is Wednesday and Thursday. I will, except for the two full-time Zoom students, Manny and Beckett, I've got procedures worked out to get you the test, and that's fine. I can, we'll still do that the way I've normally done it with you guys. But for everyone else who's in the hybrid schedule, you will test in my classroom on the day you're here. So group 1 students will test on Wednesday in my classroom. You'll get the link to the test that day. The group 2 students will test in the classroom on Thursday. You have one class period to do this test. I've said it yesterday, I'm saying it again, you need to work quickly. I think there are 25 questions on the test, and one class period is plenty of time. There shouldn't be any need for extended time on this test. All right, so second, Friday schedule. I don't know if they've sent anything to you or not about Fridays and what they're going to look like. But basically, your morning time is mentoring. You'll be logged in with your mentor from 8:10 to 11 o'clock. That allows time for a second step lesson or two. It allows time for individual mentoring where your mentor teacher can put you in breakout rooms and just have one person at a time come into the breakout room and do your mentoring like we normally would. So, but it's an extended period, and when you're not actively involved with your mentor, you're supposed to be doing PLT, working on focus areas or whatever. So that's what mentoring will look like on Fridays. At 11 o'clock, there's a scheduled break, so you can log off, you can go stretch your legs, do whatever, and then at 11:10 a new block of time starts. 11:10 to 11:40 is algebra class. So there's lots of other things on the schedule at that point, depending on what department teachers are in. But for math, there's a block of time there that I have where I can do algebra class. Now, you may have some other teachers ask you to Zoom during that time. If they ask you to Zoom during that time, you have to go when a teacher asks you to Zoom. It's just like getting a note in a classroom and saying, come see me, you got to come see that teacher. But please talk respectfully to that teacher and tell them that there's an algebra class scheduled for that time. Would you be able to Zoom with them another time during the day? So there are openings on the schedule until 2:10 on Fridays. So you need to think of Fridays from 8:10 to 2:10 being your regular school day. And I don't know about, you'll have a lunch time built in after that, and it may be that after 11:40 you don't have any teachers that have asked you to Zoom in. There's teachers with office hours, or there's teachers who have openings if you need to talk to a teacher during a time. But if you don't have a teacher ask you to come after 11:10, you may pretty well be done at that point. But you will always have algebra class at 11:10 on Fridays. So I know it's going to be weird. It's a different schedule and all that, and we'll get used to it. But just plan on every Friday at 11:10, we've got algebra. This is because high school does have classes on Friday. They're a little bit shorter, just like this one's a little bit shorter than our normal class, but I've got to do a Friday class with you guys in order to keep caught up with the high school. If I don't do this, then we'll fall behind. So, all right. So I think I can answer questions about that when I get back. And let's look at the last 5 questions on the review. So the amount of money spent mailing packages of Fizzlers to overseas customers varies directly with the number of packages sent. Whoops. If 29 Fizzlers are mailed for $464, how much does it cost to mail 18 Fizzlers? So, doesn't matter what a Fizzler is. What matters is this phrase right here, varies directly. That should set off little alarms in your head about what's going on. We know that if we see varies directly that we have a proportional relationship. We know we're going to need this equation, y equals kx. And we know that in order to find k, we need this equation, k equals y over x. All right? So they're not identified as x's and y's in this. You need to remember where things go in these proportions when we set them up. And we have a rule that tells us that money always goes on top. Money is always the y. So we've got money here. So we just need to find our k value is 464 over 29. So 464 divided by 29 is 16. So what does that 16 mean? It means that each Fizzler costs $16 to mail to the overseas recipient. So $16 per Fizzler is what the cost is to mail it. So the question is, how much does it cost to mail 18 Fizzlers? Well, that's where this equation comes in, y equals kx. We would write our direct variation equation as y equals 16x. I know that the number of Fizzlers sent is x, so I would just do y equals 16 times 18. 16 times 18 equals 288. So $288 is how much it costs to send 18 Fizzlers. All right, so direct variation equation. We need to remember these two things here, proportional equations. All right, here's another one. Suppose y varies directly as x. So there's that key phrase. We just talked about it. Write a direct variation equation that relates x and y, then solve. So I've got an x value, I've got a y value, k, and I noticed earlier I typo on this one. This should be a 16. This is going to make our lives easier. I was typing after my bedtime when I put that on there, so I hit the wrong button. So this should be 64 over 16. All right, and that would be k equals 4. 64 divided by 16 is 4. All right, so now we have our k value, so I can write my direct variation equation, y equals 16x. And then it asks find x when y is 88. So this one's a little bit different. Instead of substituting for x, we're going to substitute for y and solve for x. So it's, I'm sorry, notice what I did here. K is 4, not 16. I was thinking back to the last problem. So y doesn't equal 16x, y equals 4x. Sorry about that. I hate to confuse you guys, but this is the k value right here. So that's where k goes, is right there. So now I need to substitute 88 in for y. 88 equals 4x divided by 4, and 22 is x. So that's the answer right there that we're looking for. All right? Hopefully that's my only mistake of the day. Determine if each sequence is arithmetic. If yes, state the common difference. So look at a sequence of numbers, and if it's arithmetic, then it needs to be doing the same thing from one term to the next. So from 1 to 4 is plus 3, from 4 to 7 is plus 3, and from 7 to 10 is plus 3. So since every term does the same thing, it is an arithmetic sequence. So this one would be yes, and then the difference is just that step. What's it doing every time? It's going up plus 3, so the difference is positive 3. Okay? Let's look at this one. From 3 to 5 is plus 2. 5 to 8 is plus 3. 8 to 12 is plus 4. Now, this is a predictable sequence. I could tell you what the next three terms are, assuming that it keeps doing the same thing. Where it's going up, the next would go up plus 5, plus 6, plus 7. So this is a sequence of numbers that is predictable, but it's not arithmetic because 2, 3, and 4 are all different numbers. So we can't say that it's arithmetic. So this one is just no. All right, this one from 5 to 3 is minus 2. 3 to 1 is minus 2. And 1 to negative 1, that's minus 2. So this one is another yes. And the difference here is a negative 2. So if the sequence is going down, then it needs to be a negative number. All right. This one I saved to last because it's kind of ugly with fractions in it, but it's really not that bad. If you think about what's being added each time here, this one would be, if we change the names of these fractions, this is 3/6, 2/3 would be 4/6, 5/6 obviously is 5/6, and then this would be 6/6. So what's happening every time? This one's adding plus 1/6. From 4/6 to 5/6 is plus 1/6. And then from 5/6 to 6/6 is plus 1/6. So obviously, since it's going up by the same amount every time, it's a yes. And the difference is a positive 1/6. All right, so don't let weird fractions throw you there. Just think it through about what's going on with those fractions, and you can do it. Another sequence question. Find the next three terms of each sequence. So this one tells us that we do have an arithmetic sequence. We just need to find the next three terms. So 18 to 11, that's minus 7. 11 to 4, that's minus 7. 4 to negative 3, that's minus 7. So we see that it's going minus 7 every time. So the next three terms would be negative 10, negative 17, and then negative 24. All right. From 129 to 147, that's a little less obvious. Those are bigger numbers. So all I have to do is do 147 minus 129. And that's a plus 18 difference. 147 to 165 is plus 18. 165 to 183 is plus 18. So all I have to do is 183 plus 18. Next one is 201. Plus 18 would be 219. And then 219 plus 18 is 237. So again, all you have to do is fill in the next three terms. All right, last question. Write an explicit and a recursive formula for the sequence. So we have a sequence here. To write formulas, recursive and explicit formulas, I need to know two things. I need to know a sub 1, the first term, and I need to know the difference. First term is very obvious. The first term. A sub 1 is 7. All right, the difference from 7 to 4 is minus 3. 4 to 1 is minus 3. 1 to negative 2, that's minus 3. So it's a negative 3 is the difference. Now I just have two forms that I need to put these numbers into. So for a recursive formula, we always start out like this. A sub 1 equals 7. A sub n equals the previous term, a sub n minus 1. And in this case, it would be minus 3. And that's it. That's the recursive formula. The explicit formula, I'm going to give you the standard form of the formula first. The way the formula looks is a sub n equals a sub 1 plus n minus 1 times d. Okay? So all I have to do is substitute in a sub 1 and D. So A sub n equals 7 plus n minus 1 times negative 3. And then remember, we need to simplify this. I had you do that on the last assignment that we did on explicit formulas. So A sub n equals 7 plus negative 3 times n would be negative 3n. And then negative 3 times negative 1 would be plus 3. So we've got it in this form. Now we just need to simplify it. A sub n equals 7 plus 3 is 10. And then plus minus 3 would be minus 3n. So A sub n equals 10 minus 3n. Okay? This is what it should look like when we're all done. You need to remember how to plug things into the formula so that you can simplify it at the end. All right, so that is the end of the review there. The questions on the test will all look like something that you have on that review. So as long as you've got that review filled out and you can study that and know how to do all those, you should do fine on the test. I don't feel like the test is super super tricky, super difficult. It just kind of covers all of that stuff that we went over in chapter 3, and it covers it in very basic terms. It doesn't get well, like I say, I just don't think there's anything on here that's trying to trick you. I think as long as you know your stuff, you'll be fine. All right. I'll see you guys, hopefully, by the time you finish this video, I'll be here. So take care.